Hello everyone and welcome. Today I would like to talk about binary tree maximum path sum. This is considered a hard question. So what's the path sum? A path sum of a path is the sum of the nodes value in the path. Very simple. This question also says the path does not need to pass through the very top root. Here's an example of the maximum path sum. 2, 1, 3. So the maximum path is 2, 1, 3 or 3, 1, 2, either way. So how do we solve this question? Here's a tip. When the question asks about the maximum of something, consider using dynamic programming, which is to solve a problem by solving simpler subproblems in a recursive manner. Using dynamic programming, we can simplify the overall complicated problem by solving a simpler subproblem. Here, the subproblem is to figure out the maximum path sum of a three-node unit, as in here. In this unit, there's a node, and there's a maximum non-negative gain from the left node, and the maximum non-negative gain from the right node. So there are three components here. Here, the non-negative gain means the gain will be zero in the worst case scenario and will be positive in the other scenario. This property makes the computation a lot easier. Importantly, it should be pointed out that these two maximum non-negative gains are not simply the left and right nodes values. They are non-negative gain to simplify the computation, and there are only 4 different possibilities of these local path sums here. Here are 4 possibilities. So if you ask, how about left and right only? Well, that's also covered when the node itself is left or right. The remaining questions include 1. Which of these 4 possibilities has a local maximum path sum? 2. Which node gives us the global maximum path sum? 3. How to obtain this maximum non-negative gain from a given node? Here are the answers to the remaining questions. So number 1, which of the 4 possibilities has a local maximum path sum? Well, the answer is simply nodes value plus left maximum non-negative gain plus right maximum non-negative gain. Because if the left maximum non-negative gain is 0 or the right maximum non-negative gain is 0, they certainly will be just 0 and wouldn't add up to the nodes value. Otherwise, they will add up to the nodes value. Number 2, which node has the global maximum path sum? To answer the question, we'll simply traverse through each node recursively and track the global maximum as the maximum or global maximum and the local maximum. Number 3, how to obtain maximum non-negative gain from a given node? Well, the answer is here, and I will elaborate what it means in the next slide. To obtain the maximum non-negative gain from a given node, we'll use the example here, this left child node. There are only 2 paths that this left child node can traverse from itself. One is go to the left and the other is go to the right. Importantly, unlike the 3-node unit, here we can only go to the left or to the right. And that's why we have this part to decide whether we should go to the left or to the right. Finally, this part, n plus the nodes value, as compared to 0, will give us the maximum non-negative gain from that given node. Here's a summary of the dynamic programming solution to this question. There are 3 steps in general. First, traverse through the nodes recursively to find their local maximum path sum. Second, keep track of the global maximum path sum. Third, the maximum non-negative gain from a given node is given by the following. Now that we have all the background covered, let's write the code. So first of all, we will define a function. We call it the maximum non-negative gain, and it takes the node as an argument. And this function will return the maximum non-negative gain from a given node. Okay, and then if node is none, we return 0 as the maximum gain. And here we want to have two variables for the left maximum non-negative gain, which is simply using the left node and call the function. We also have this maximum non-negative gain from the right node. Simply again use the node.right and call the function. And then the local maximum will be the node's value plus the left maximum non-negative gain and the right maximum non-negative gain. And then we keep track of the global maximum as the maximum of the global maximum and the local maximum. And the global maximum will be a non-local variable, so we will declare that using a non-local statement. Okay, and the global maximum can be initialized to be negative infinity outside this inner loop. Outside this inner function. And finally, we'll return the maximum non-negative gain from this given node as the maximum of 0 and the node value plus the maximum of left maximum non-negative gain or the right maximum non-negative gain. Okay, and then we'll call the function while feeding the loop as the argument. Finally, we return the global maximum as a result. So that's the code for this question using dynamic programming. Let's test it to see how it works. We submit, pending, and done. So it's about 80 milliseconds. It's pretty good. Finally, we can analyze the code for complexity. So the code has a time complexity O(n). As we can see, it traverses through the nodes at least once. And it has a space complexity O(h). H is the height of the tree, as it calls the left and the right node recursively. And that's all for this video. Hope you find this video to be useful. This question and its solution is based on dynamic programming. It's a little bit difficult, but with some practice, you should be able to get a hang of it. If you like, please feel free to subscribe for more videos. Hope to see you next time soon, and goodbye.